Okay, grade 11s, if you guys could just take a break from what you're doing and take a look up here. This is a concept that we touched on in our extras unit last year in grade 10, but today I want to flesh it out as a complete full unit for you guys as to what exactly it is. So I'm going to explain the concept, okay? We're going to do an example, and I'm going to go into much more depth than I did when I first introduced it in grade 10 to you guys, okay? So basically, in the process of programming, as you'll learn this year more than any other, the idea is to break the problem down into multiple components, okay? Individualized instructions that the computer can work on. So in this process of software development, using methods is a key part of that, and you're going to find once you get into using methods, it'll just become part of your programming. Now, the term method has also been called function, a function, or a procedure. So if I use those words, function, procedure, or method, they all essentially mean the same thing. And I'm going to turn for a second to, oops, let me just zip ahead here. Okay, because you have seen this before. If, depending on the math you're taking this year, you've seen this. And in math, we call that a function, okay? So when you use this function in math, you'd say, what's the f of 2? And what would happen is the 2 would substitute for the x, and so the f of 2 would be 4, okay? This is essentially the same concept here. It is the same concept as it was in math, just now applied to computer science, but in a more practical way, okay? In math, this is a function in math that's used for notation purposes. But in computer science, a function is got sort of more meaning to it. Another way I like to describe it, other than that mathematical way, is that a function is like a little machine. I'm going to draw this little machine here, okay? And let's say this machine makes things cool. It's a cool machine, okay? So what you do with this machine is you put input into it, okay? And it will provide you with output. And really, that's what a computer program is as well, right? If you think of a game, you provide it input, it provides you output. The input could be keyboard commands or mouse clicks. The output might be visuals on the screen or sounds coming out of speakers. Input, do something with it, output. And that's also what a function is. A function is like this little machine that can have one or more inputs and possibly provide you with an output. It's also possible that the machine will not provide an output. It's also possible it will have no inputs. But we're going to go over that today and as I explain sort of what I mean by that. Now, this idea of breaking down a problem is something I introduced way back at the beginning of grade 10 in just problem solving. You may remember this way back, this idea of a top-down design, where you can take a simple problem and, a problem and break it into simpler problems and then break those into simpler problems. At the time, this was just a problem-solving activity. But in reality, this will now become part of programming once you start using methods, okay? You don't have to necessarily draw it out, but just that type of thinking goes into method development. Okay, so this allows you to take a big program and write it in smaller pieces. Some pieces, this is very good for team development. So thinking ahead to final project, you can split a program up into different methods and different programmers can write the different methods. Some of the programs, some of the methods might be built into the programming language, okay? So here's a simple example. Let's say you were writing code and it had to take a number and raise it to a power, like 10 to the power of 7, okay, or 20 to the power of 10, okay? And let's say you had to do that several times in your program. Your code might use a loop to do that. So if you used a loop, you could loop through and keep multiplying that number by itself up to the power that you were reaching, right? So it's saying right here power, so the result equals result times the value. So it would keep multiplying onto itself, and then it would spit out the answer. But then let's say you had to do it again. And so you'd repeat that loop. So the first instance where you might want to try to use a method is if you find your code repeats itself. If you're finding that you're writing the same kind of code over and over again, you could automate that code into a method, okay? It will shorten up the code and create a more efficient type of code by creating the method. So again, silly to write that code over and over again, okay? So what you want to do is take that code and produce a method with it that will be easier to use and more usable down the road when you keep repeating yourself. Okay, so let's take a pseudo example. I'm going to boil some water, okay? That's the problem. If I take that problem and break it into tasks, I could look at things like this. To boil water, I got to go find a pot, I got to fill it up with water, I got to bring it over to the stove, and I got to heat up the water. That's the tasks. Each of those could be broken down. To find a pot, I got to move to the pot. Okay, here's the pot, I'll move to it, right? Move to the faucet, move to the pot, move to the heat. I'm going to have to grab those objects, right? Grab the pot, grab the faucet, grab the pot again, and grab the controls on the stove, right? I'm grabbing something. And then I'll move to the sink, rotate the handle, move to the stove, rotate the knob on the stove. It's a real basic breakdown of the tasks of boiling water, but what you see in this is repeated instructions. I'm grabbing multiple times here. Does anyone see anything else that's repeated in that pseudo example? Yeah, move to, that's right. Notice move to, but what's the difference between this move to and this move to? The thing, yeah, which is the parameter or the object that's changing. You might even call it the variable that's different in each one of these. Okay, so move to the pot is different than move to faucet only by the difference between the object you're moving to. So this gives you an idea as you sort of plot this out that I could introduce methods into this and really shorten up my code and optimize my code. Okay, so this is what it might look in pseudocode, okay? To boil water, I find a pot, fill it with water, bring it to the stove, and heat the water. To find a pot, I move to pot, I grab, I move to sink, release, move to faucet. So here you can see in pseudocode the idea that this task, boiling water, involves smaller tasks which themselves can be broken into tasks. And this idea of moving to, or grabbing even, I didn't put it on there, but grabbing just changes in the parameter that it's moving to, like the pot or the sink. That's the pseudo example, okay? How does this work? Well, the code but basically works like that. So it goes in and tries to run this code called boil water. The first thing it encounters is this thing called find pot. What happens is the code stops right there, jumps down, and starts running find pot. So the second it gets to there, it jumps down and starts running this one. When it gets down here, it might find another one, and it'll jump over to that one and start running it. But let's say it does, and it finishes all the code inside of find pot. Then it goes back to where it was finished here and now goes to the next one. So now, by introducing methods, your code's going to be jumping around to different places. Okay? So it's a little bit harder to follow, but it's going to actually make the problem solving a little bit easier in its concept. Okay. So methods can run other methods, which breaks the problem down. Okay? So a way you can think of methods is instead of writing one large program, you're now going to be writing lots of little programs inside of the bigger one. Okay, here's another pseudo example. Here's a day's work for me, walks. I go to school, I work, and then I go home. That's my day. So what does work look like? Well, I have my coffee, I bug you students, and I do some photocopying. That's my day. I get paid lots of money to do that, okay? In code, it might look like this. To go to work, I go to school, work, and go home. What does work mean? Well, I just told you. I have coffee, I bug the students, and I photocopy. What does have coffee mean? To have coffee, I pour and drink. And I could keep going. I could define what pour is. Lift, turn. That is now a simpler problem. Pour, lift, turn. than this problem, go to work. That was a much more complex problem. So this idea of using methods to break it down, you eventually get down to problems that are so simple to solve. So what turned out to be a huge problem at the start is now broken into lots of little problems. That's how it helps your problem solving, by making the problems smaller. A good program will contain lots of different methods. So a classic example is, let's say you guys were all working for a video game company, okay? And let's say we're going to make a program for a flying game, a World War II airplane battle game, okay? And let's say I was the leader of the company, and I took this game that we're going to come up with, and I decided, you know what, let's break it down. So I said, okay, Nick, I need you to write code to make the sound of one machine gun bullet. That's your job. You got to go find the sound, you got to write the code so that when I need it, it'll make the sound of a machine gun bullet. Bang. He goes to work. He's got that job, he goes heads out and does it, okay? So then, let's say I assign Stephen the job. I say, Stephen, I need you to work on the physics of the gun aiming. So you got to write code so that when the user presses two different buttons, it'll sort of aim the ship or the airplane's gun so that it can shoot in different directions. He'll go to work. But eventually, with his code, when the gun is fired, he will use Nick's code, because he will probably have a loop, so every time the machine gun goes, it'll just keep using Nick's code over and over again to make that gunshot sound. Bang, 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 bang. Stephen won't care how Nick wrote that code. All he cares is, did it work? Does that code work? So in a multi-programming environment, you can divide up the tasks really well. And what this also leads to is these methods that you're building, called programmer-defined methods, that perform a task and return a result when they're done, okay? Some of these methods will be built into programming languages, like Java has some built into it. But to use a method, you have to what's called call the method. You have to use what's called a method call. Okay, so let's do this in Java, and we'll get to the example right away. Okay, so here's the basic ways you create methods, okay? And these will change. You state it as either public or private, okay? And that won't matter too much right now. When we do our classes unit, you'll get a better idea where that's important. For now, you'll use the keyword static, okay? Later on, I'll kind of explain why, but for now, that just means, again, very much like public, that it's a shared method. Then you'll define what comes out of this method, or its return type. Again, I'll go over the details of that in a minute. Then we give our method a name, and then we use rounded brackets, and then curly brackets to define the structure of the method, okay? So anyways, let's do this in NetBeans. So start up NetBeans, and let's build up a project. Call it method example or something like that. And I'm going to suggest that you go ahead and just leave this checked off, create main class. It'll just automate the process. It's just a little bit faster now to let it do that for you. You don't need to worry about adding your own class from scratch anymore. You got the idea down now. And I think that you guys have been doing that, I think, for the assignments you've been working on. Okay. Okay, so let's do this. Okay, so inside a main would be where we're going to use our method. Okay? And Java doesn't need to know what the method is called when you first make it. It'll get confused, but that's a good thing, and I'll show you why. So we're going to make a method that just makes a star get output. It's the simplest method in the world. We're just going to call it makeStar. Okay? So here's the way you would call a method. Not create the method, just call the method. is you define what it's going to be called. So I'm just going to say make star. And the round brackets right there will tell NetBeans that this should be a method. Now it'll give you an error because it doesn't know what this method is. But that's okay. We'll fix that in a second. Okay? Now notice the style. The style is very much like a variable. Using that camel casing, it starts in lowercase. So you might think it's a variable at first. The way you tell it's not a variable is by those round brackets, just like you would see kind of in math that indicates that it's a method. Okay, so there it is. Now if we want to, we could go and manually write how that method looks ourselves. But luckily, NetBeans has already got a solution for us. It's got a light bulb on the side and it says, cannot find this symbol. Method make star. So it knows it's a method. And it says, do you want a hint? So if you click on the light bulb, it says, hey, do you want me to create the method? And I'm going to say yes. So I go and click on that line, and it'll pop in a method automatically for you. It'll probably put a line in the code for you that says something about throw new exception. You can delete that line. That's just a sort of an error line just in case. I've set mine up so that it doesn't do that anymore. So this is what make star looks like, and it's just the way I just said. You define it as public or private. NetBeans will say it's private. That's fine. Then it'll have the keyword static. Okay, that's fine for now. And then this word, void. What does void mean to you? Like, without thinking of computer science, what is the word void? Space or what else? Empty, yeah, or nothing. And that's exactly what it means right now. This method, make star, gives you back nothing at this point, which is fine. I don't need it to give me back anything. I just need it to make a star appear on the screen. So let's do that. Let's do an output of a star, just like that. I want to output a star. So this is my code now. It's very simple. When your program runs, always it goes to main first. Then it comes down here and it sees this thing called make star. And it goes, well, what's that? Oh, that's this thing. So it jumps over to here, runs this line of code. When this line of code is done, it comes back and looks for more code. Now, we happen to not have any more code. But if we did, that's where it would run. So you could test this if you want. I don't think that's necessary. But let's try this again. Let's make another method. Now we can make it up here like we did with make star, but you can also just write the method yourself. So methods, let me just back up and show you what I'm talking about here. Methods, let's get rid of some of this comment for now. Methods are themselves built using curly brackets. So main, believe it or not, is a method. Make star is a method. We just made it. Okay? But notice that these methods and their brackets are still inside of the class itself. The class has its own brackets, so methods are things built within the class. So you got to be careful about where those brackets fall to make sure your methods aren't going to get screwed up. So if you're going to write your own method, you've got to do it under the other methods, but before that closing bracket, or it will screw up the structure there. So let's make our own method. Let's make it a private, static, void method, and let's just call it end. We're going to end the program. So it's basically the code we learned, system.exit bracket 0. So that's how we end the program. So now let's use this method. Let's go up to main and let's call the method. Now, here's something neat about NetBeans. It gets smarter as you type your code. So if I just type E, let's say I forget how to spell the word end. I know it's possible. And I press Control Spacebar, it will now recognize your methods. So there's end in the list of automated code. It knows that end exists now. So that makes life a little bit easier for you as a programmer. So now my code would make a star and then end. Okay, that's pretty cool. Not that useful to me yet, but it does. I'll even give it a run just to make sure that it actually works. So it runs make star, and then it runs end, and end actually terminates the program, so that should end the program itself. And again, remember, it branches off from make star, runs the code, comes back, goes to end, runs its code, and there it is, 1 star. Big whoop, it worked. Okay, let's make star a little more useful to us. So let's focus on make star itself. Make star just makes 1 star. But let's change the structure of that method from make star to make stars. Add an S to it. And inside those round brackets right there, we're going to add what's called a parameter. Okay? A parameter is essentially a variable. So I'm going to make a little integer called number. And what the number is going to represent is how many stars I want to make. I want to make this many stars. Okay? So my code itself isn't quite right yet. I got to modify my code. As well, you'll notice now that there's an error up here, because that thing no longer exists anymore. Something called make star, and the light bulb I would actually suggest to you, it would suggest making it again, which we don't need to do. So if you make a modification to a method down here, you've got to also make a modification to where you called the method up there. So let's do that. Let's go up top, and let's call it make stars now. But it's still not correct, because I'm asking it for a number. So I need to give it a number up here. So let's give it a number, like 10. Okay, so here's how it works now. This number 10 right here will be what's called passed into that variable. So when it calls make stars, the number 10 gets placed into this thing. Because remember, that's just a variable. So now that variable holds the number 10. If I called it with a 5, it would pass the 5 into this thing. Okay? So now let's modify the code. The code should be fairly easy to modify. It's just going to use a loop. So I'm just going to add a loop, a for loop, and I'll go up to number. And then I'll take this line and put it inside the loop. That's it. That's all there is to it. Okay? So now I say make 10 stars. I could run my code, and it makes 10 of them. I could put 100 here, and it would make 100 stars. What I've done now is I've made the method more useful by adding something called a parameter. Okay? Okay, let me jump to PowerPoint here for a second. This example is also in the notes. So just real quick, and I'm sorry if some of you didn't get it. I'll put it right back up in a second. So there's the example of simple make stars. Okay? You call the method, as it shows here in the notes, by using the same name, which jumps down to the method itself. It calls, that's the term for it. It calls the method. Okay? Then I went on to this idea of parameters. Okay? So often a method requires more data to be useful, and that data is passed in what's called a parameter. And again, this is just like in math. They use that same sort of terminology. And believe it or not, you've already done this. You've already done this with built-in methods. J-option pane is a built-in method. We don't know how the code inside of J-option pane works, and we don't need to know. That's called black box programming. The method itself is inside a black box, which means we don't need to see how the code works. We just need to know how it works. A lot of modern society works on a black box philosophy. A lot of people will be able to use a television remote without ever knowing how it works. A lot of people use their cars without knowing how it works. They don't care how it works. They just need to know, what inputs do I give it? Like for the remote, what buttons do I press? For the car, which pedals do I step on and which wheel do I turn? You need to know how to use it. You don't need to know exactly what's going on inside the car itself. That's this black box idea, and it now applies to programming. You don't need to necessarily know how the method works. So if we go back to the video game example, Stephen does not care how Nick wrote his code, as long as it works. All he needs to know is, how do I call this method, and does it need any parameters? And that's the way show input dialog worked for you. When you called show input dialog, all you needed to know was, what do I put into this thing? What goes into the machine? What goes in and what comes out as a result of it? That's all you needed to know. And that's the idea behind that black box programming. Okay, so now we're going to use these things called parameters. Okay? A method can be passed a value into the method itself, and that's called an argument. So there's a slight difference here in terminology. Which is a parameter and which is an argument? So let me explain the difference. Right here, when I create make stars, int number is the parameter. Up here, when I call make stars, that thing called value is the argument. In our example, the one we just coded, number right here is the parameter, and 10 is the argument. They're essentially the same thing, but I just want to kind of stick on that for a second. This is the argument being passed into the parameter. Okay? They essentially are the same thing. But you could, one of the ways that it kind of helps to think about that is if I called it again. If I went make stars 3. Now what's going on is 3 is the argument going into this parameter versus 10, which is the argument. Okay? It's the same parameter, but different arguments going into it. So that's maybe a way you could think about it. Okay. Now, I just have in the notes a couple different examples just to show you that it doesn't matter what the parameter, as long as the argument asks for an integer, I can pass it any type of integer. So in this case, I'm passing it a constant or a final. That's fine. It's an integer. It'll accept it. I can even send it more complex things like an equation. As long as that equation becomes an integer, no problem. Java will accept it. So the arguments can be, as long as the argument matches the parameter, the argument can be anything you want it to be. And we can pass it more than one thing. Okay, so let's do this in our example. Make stars was cool, but instead of make stars, let's write a different method under make stars called make things. We're going to ask it to make 10, but not just 10 stars, but 10 things. And we're going to define what the thing is. So maybe I'll use an @ symbol. So I'm saying, I want you to make 10 @ symbols. That's what I want. So I'm going to make that method. So I'm going to use the light bulb. It's just faster. And I'm going to create the method called make things. And it often drops it at the bottom. Okay, so here's make things. So now the cool thing is, if you use the light bulb with something that you've already got parameters for, it'll actually create the parameters as well. Now I'm just going to move this up, just, you don't have to, but I'm just so that we can see both at once. So there we go. Okay, so here's what it knows. It knew that it had to make something called make things, so it made that. It also knew that it needed 2 parameters, and it tried to figure out what they were. Well, it goes, well, the user wants a 10. That's probably an integer, so that makes sense. I'll make it an integer. And then they wanted something in quotes, so I bet you that's a string, so they made a string. But NetBeans has no idea what those 2 things represent. It doesn't know what they are, so it has no idea what to name them. So NetBeans is really crappily just named it I, because it doesn't know what it is. And look at how bad that is. It named the string string. So NetBeans will do a pretty good job, but let's rename those 2 parameters. Instead of I, let's just call that number. And instead of string, let's just call it thing. That's the thing that I'm going to be making. String thing. Okay, so it's the same for loop. Let's make the for loop that goes up to number. And I'll system out my thing. That's it. That's the code. It's the same logic. It's not tricky logic. It's just a loop that runs from 0 up to the number. Well, actually, 1 before the number. So it counts up to the number, and it just prints out the thing. Print the thing, print the thing. And the thing is a string. So now I'm saying make me 10 @ symbols. So let's run it. Let's make sure it works. It should make 10 stars and then 10 @ symbols. And it did. Look at that. It did exactly what I told it to do. And then it ended the program. You can add as many parameters as you want. All you have to do is separate them with a comma. That's how it separates the parameters. Comma, comma, comma. And that's exactly the same way it separates the arguments, by just placing a comma between them. So you now can construct methods that do whatever you want them to do. Okay, so in the notes you see that example as well. Okay, by just placing a comma in between the parameters and between the arguments, you get a method with multiple parameters. And again, you can have more than 2. You can have as many as you want. So you can have 0 parameters, 1 parameter, or any more than 1. But the order matters. Okay? So if I say I want an integer and then a char, I better give it integer char. I can't reverse those two because then NetBeans will get confused. The order I call them has to match the order I've defined them. So the order matters. Okay. So now I want to introduce the third thing about methods. Okay, so you know what a method is. You know what parameters are. Now we go to the other end of the spectrum. So we now know that into a method you can have multiple inputs. Could be 0, could be 1, or could be anything more than 1 inputs. The method will do something. But at this point, it doesn't provide you anything back at the end of the method. Right? Like in math, if I go back a slide, the f of 2 gives you an answer back. The answer comes back. But with this thing, we have at this point no outputs. Because in our defined methods, we use the word void, which means nothing. Okay? So we're going to change that. We're going to write a method that sends back a value. Okay, so let's do this. Let's just write it from scratch. We won't, and it'll be a private, static. Okay. Now instead of the word void, we're going to put the word int. So this will return an integer. And this method is called random. Whoops. So this is going to be the random number formula generator. And random will have 2 parameters, an int min for the minimum and an int max for the maximum. So what this method does is it'll return, or it'll send back, a random number between, say, 1 and 10, or 50 and 100, or 1 and 52 if it was a card game. It's code that you guys have already written, so I don't need to explain it in too much detail, but it's how we're going to actually produce that random number. Okay, so let me give you the lines of code. First, we need to work with doubles. So double the low value equals the double cast of min. So I cast minimum into a double. I do the same thing with the high value. The high value is a double cast of the maximum. So I turn those 2 integers into doubles temporarily. Okay? My random number, I'm just going to call it rand, equals high minus low plus 1 times math.random, that's where you get what's called the random seed, plus low. So that will generate my random number between high and low, which is between min and max. And then I'll finally return that. But before I return it, I have to turn random back into an integer. So int answer equals int of rand. And then here comes the new line. The last line of this method is the keyword return. Notice it appears in blue. I return the answer. Okay, so here's how this method should work. Let's say I give it the numbers 1 and 10. I'm going to call this method with the numbers 1 and 10 as arguments. It'll then substitute those into the formulas here, and it'll generate 1.0 and 10.0 into L and H. It will then use those numbers in this formula along with this thing, which will be a randomly generated value from some code. And by the way, that's a method. Random itself is a method within that library. It's a method. How do I know? Because it's got the round brackets. That's the clue. And let's say it generates a 5. So actually it would generate a 5.0. Actually it might be 5.01. It doesn't matter. It's some decimal number is generated there. Then I turned that thing into an integer, which gets rid of the decimal part. So now it's just at 5. And then I take that answer, which is 5, and I return it. Now what does that mean? It means that this thing will be returned somewhere. But I haven't used this method yet. So let's use it. Let's go back to main, and let's add the very first line into main. Int number equals random, and let's make a random number between 1 and 10. So that's exactly what I just said to do. So right here, I have the two arguments, 1 and 10, that are fed into the method. It, let's say, generates a random number of 5. So at the end, a 5 is generated here. That 5 is returned to here. So now number will contain a 5. Sweet. That's what I wanted. So then why don't I just use that number right here? I'll just say number. So now it will generate a random number of stars. So I'll play it, and this time it generated 3 stars. I'll play it again, 3 stars. Seems to be generating 3 each time. Oh, no, there, 4 that time. And that time more than 4. So it is a random feature. Okay, so hopefully you now recognize one thing that I hope you get. You probably did this in the first unit. You probably wrote this code for different problems, because a lot of you submitted up to 7 or 8 different problems for the first unit. Why reinvent the wheel now? What you can now do is take this method with you when you go and start a new problem. Copy that method over to the next problem, and then it just shortens your code up. So whenever you want a random number, you just call it. You call it from the code that you have. Later on, when I show you how to do classes, you'll build a class where you can do all that within it as well. But I don't want to put the cart before the horse. But the idea, again, is methods create reusable code. We can reuse our code over and over again. Okay, in the notes, it explains this through example as well. So here you can see I made a method called cube of. It says the cube of 3 is, and I call it with the argument 3. It returns a result. That result is a double, and the double is the result of number times number times number. And again, you can optimize your code like you can see here. Well, in a second I'll show you. So that right there, the word double, defines what type of value it's returning. A void method returns nothing. Here you can see I've shortened the code in cube of, and again, you can get a little bit more complex. I say number times number times number. You can put a formula right in the return. So how could I use that in the code that we just wrote? Well, I'll show you. Instead of just going int answer, I could have just put this right here. right? That would have meant the same thing. Now again, you've probably done factoring in math class. If I do that, couldn't I have just put this in place of this? Maybe I have to put big brackets around the whole thing, but wouldn't that mean I could do that? Yes, I could. And you could even go another step. I could just take this in place of low here and here, and I could put this in place of high right here. In reality, that method now becomes one line of code. But the question is that a good line when you look at it? It's now kind of so complex with all the brackets and stuff that you might think it's more efficient. And it might be argued that it is because it's one line of code. But when you take this method into your next programming problem, will you understand what it means? Maybe. That's kind of a personal thing. I happen to think that maybe spelling it out a little bit like that might be a better way to write the method, just because it kind of is a little more explanatory. Especially here at the beginning stages, that I can kind of see things in action rather than kind of make it more. And again, that depends on your comfortability with math, right? If you are okay with big, long factored equations, then there's certainly a way you can do that. Okay, I'm not saying one is more right than the other. It's just personal preference at this point. Okay, we're doing a lot today. I'm surprised how much we're getting done. I want to then just end today with this. Methods have their own way of being commented. Okay, I'm going to show you the classic way to document a method, and then I'm going to show you a specific way. So the classic method for documenting a method is to write a comment that is expected at the beginning of each method. And the traditional way is to use these four things. A purpose, describe what the method does. Preconditions, those are the inputs to the method, or the parameters. Postconditions, which are the outputs of the method, or what it returns. And does this method rely on any other methods? Does this method call any other methods? And here's where I'm going to sort of stop for a second. We're going to throw one more quick example up there. So let's make one more method here. It'll be a useful method. It'll be a private, static, void method, and it's just called output. It takes one parameter, a string of text. Okay, it's a very simple method just called output. And all it does is it outputs the text. It calls system.out.println text. That's it. It's as simple as can be. So you're thinking, well, what's the point of that? Well, I'm going to go down to our method called makeThings. And instead of writing this, I'm just going to switch that to output. Right there. And similarly on makeStars, our method called makeStars, I'm just going to switch this to output. Actually, instead of that, here's what I want you to do with makeStars. Okay? So here are the changes. I want you to change makeThings to say output thing, and I want you to make makeStars say makeThings 1 star. Or sorry, not one, number. Right there. Okay. Let's shift this around a little bit. Get rid of that for now. Just move that down. Okay, because here's what I want to show you guys what's going to happen here. I know it's hard to read because it's kind of far away, but I think you guys can still see it. Okay, I want to focus on this line right here, makeStars. Okay, so let's say it's given the number 3 right here. Let's say it randomly generates a 3. So what happens is the code will jump down to makeStars, and it'll plop a 3 into that parameter. So now it goes to write the code, and it goes, oh, you want to make some stars? Well, I'll have to make some things. So it takes that 3 right here and a star, and it moves those into those parameters. So this now goes into there, and that goes into there. So now this is a 3, and the thing is a star. So it's passing the data along. So now it goes into a loop. It can do the loop. But when it gets inside the loop, it finds this thing called output. So it goes, oh, now you want to call something called output and take that thing with you. So now the star is passed along to here. And then finally, it prints that thing, the star, to the screen. So here you can see methods calling methods calling methods, passing the data along from argument to parameter. And that's why in the traditional documentation system, one of the things that programmers like to document is, does this method rely on another method? Because if I moved one method from one project to another, but it called another method, it would break down. So that's the 4 traditional ways. But I don't actually want you commenting that way. Here's the example. Okay? Well, that's the explanation, which I just said. Purpose is what it does. It should be brief. This is not English class. You're being really brief. Preconditions, which are what the method needs, what are its inputs. Postconditions, what comes back, what are its outputs. Does this method call any others? And here's the example. So this would be a traditional way you could document a method like cubeof. You'd say, this is the purpose, these are the preconditions, these are the postconditions, and these are the calls. And I made it look really pretty by putting a little box around it. That's old school. I actually don't want you you can, and I won't deduct marks if you comment that way. But Java, like most modern programming languages, has a specific way to do this, and Java calls it the Javadoc style. Okay? NetBeans and Eclipse and other IDEs will automate this for you. So it's not a lot of work for you. And that's the way I'm going to recommend you do it. What you're going to do is you're going to put a slash star star, 2 stars, at the top of every method. So you have this method, you put slash star star, and it'll fill in the details for you. So let's try that. Let's go to the method we just wrote called output. Actually, no, we'll start, output. So just above the method, put slash star star and hit enter. And what you'll notice is it put some stuff in there for you. It said, oh, you have a parameter called text. This is called a tag. So it's tagged that text is a parameter that you need to identify. So the first thing you need to write is, what does this thing do? And again, be brief. It outputs to the screen. That's what it does. Next thing is, what is text? Well, that's the string to output. That's what it is. Done. That's how you document a method. And as a matter of fact, that's the comment that you should now have with every method, and you don't really need to comment inside the method. There's no need to comment that line. This comment takes care of it for you. Now, that is useful, but it's more useful to you in ways you're not even aware of yet. Because I want to show you something right now. Let's go up to main. And just before I end this program, let's say I'm going to do an output. So as I already showed you, I can use Control Spacebar to have it automate that. But I don't know if you noticed this right away. When you use Control Spacebar and it shows you the method you wrote, it also reads the documentation that you just put in there. So as you build up a library of methods, it will automatically keep track of your own documentation. So like a user manual, all you need to know is, what does this thing do, and what do I put into it? Well, I put in a string to output, and it'll output to the screen. It's now a black box. Doesn't matter how you wrote that method anymore. So that's pretty cool that it does that. Let's document another one. Let's document, we'll skip a couple. Let's document random. Slash star star. Okay. This time, NetBeans has suggested you have to few things to document. What is random? It's a random number, which I can't spell. There we go. Embarrassing. In a range. What's the min? The minimum random number, and max is the maximum random number. And it added one more tag. What does this thing return? Because random has an output. It sends you something back. So what does it return? A random number in the range. Now this is an example of documentation that's highly repetitive. So you probably could do a better job of writing it than I did, because it seems like I keep saying the same thing over and over again. But that's what NetBeans has suggested to you. Okay? One other thing that's kind of neat is NetBeans can help you organize your code using these little plus minus things on the side here. So now that you've got a method done, like random, you can collapse the code inside of it. And if you just put your mouse over that, it'll show you the code. And you can also now collapse Javadoc as well. And if you put your mouse over it, it shows you the Javadoc as well. Just as a way to shorten up your code while you're working on it if you want. Okay? That's how you comment methods. Okay, so you can see that here in my notes, that I show that, and then I show that in an example right here. Same example kind of that we just did. So these things called @param and @return are what are called tags that NetBeans will suggest to you. Now, there are other tags as well that you can use, because you can use Javadoc not just on methods, but also on classes. So for example, @author, I think I explained to you guys once before, is where you put your name. @version, this would be like if you were writing professional software, like this is Windows 8.1, right, or something like that. @since is like a date tag, which will tell you sort of when you've been developing this code since. And @c is one you might even want to use as a way to sort of link this documentation to other documentation. That's a little more advanced, but you can certainly try that as well. And believe it or not, the code you put in the general description area, Java treats it like HTML. So if you know how to code HTML, you could even do stuff kind of like this here. You can put headings, you can put paragraphs, you can put link tags in there. And when it creates this, it actually uses that. So I'm going to show you this next. This is the last little piece of this. Although you're not doing this, but let's say you were professional software developers. When you've got code all documented, you can go up to Run, and there's a thing here that says Generate Javadoc. And you may even want to try this. What it will do is it's not going to run your code. It's going to run the documentation for your code. And what it generates, if it works, did it work? Here it comes. Is it'll generate a web page for you, believe it or not. A web page that is the documentation of your code. Okay? So here you can see it says methods example, and it would document it if it had code in it that it would be documented. So you can click on it, and here you can see it didn't actually show the documentation for my methods because they're private. I just want to show you one real quick thing. I'm just going to make this public. There's a way to change that, but I forgot that was going to happen. I'm going to rerun the documentation. And now, I don't know if you can see right there, it actually, that's my documentation for random, right? Random numbers in a range, the minimum random number, like it actually generates this thing for you. So that's one of the things. Now, for those of you guys who remember C#, C# did this as well. C#, it used a slightly different way. It uses 3 slashes rather than /**, but it kind of has the same format in C#. And it's pretty neat that it does that.